Okay, in the second part of the problem, what they did was they gave us a semicircle. Remember, that's just half a circle with a radius of 5 labeled, a reference triangle over here. I think they asked for the coordinates of P. We'll get those. And the arc length along here. And they started asking for every possible labeled thing. Now, what I'm going to do is just add some units to S. I'm thinking centimeters might work, inches might work, but I'm just going to call it centimeters for the moment. It'll help when we do the calculation. Now, in order to actually start finding everything, I do need to know the radius, and I can see here that the radius is 5, so that's not so bad. So the next thing I want to do, that's the only thing I can do, I think, is try to convert that 13 centimeters into the angle that corresponds to it. Now, how do we do this? We start out with the arc length, which is 13 centimeters, right? We multiply by a fraction where the bottom is a lap, the top is a lap. We wanted an angle measure on top. I'm going to do degrees first. The number winds up being ickier, but I'm thinking you might be more comfortable with it. So I want a lap on top, which is 360 degrees. Now a lap of arc length is 2 pi, and then the radius, which in this case is going to be, I think, 5 centimeters. Looks like that. Remember, the 360 degrees is a lap. 2 pi times 5 centimeters is also a lap, so this is just a fraction of, it's equal to 1, which is good. Now, why did we do that? The reason we did that is so that the centimeters would cancel. What's left is degrees. What I'm going to get, I'm not going to simplify this much, I'm going to get 13 times 360 all over 10 pi, like that. Now, I really like that angle. I want to leave it like that exactly. So I'm just going over here and writing the results like this. Now, I don't think we really need this, but if I take 13 times 360 and divide by 10 pi, 13 times 360 divided by 10 pi. Now, first off, by the way, I'm hoping I get something between 90 degrees and 180 degrees. I get about 148, so I'm going to write that in. We're really not going to use it, I think. You'll see why in a second. I'm just underlining that last digit to show that we rounded, and it seems like it's about right. 150 degrees is almost the middle, I think. Anyways, so we now have the angle. Now, why did I want the angle? So I can actually use our coordinate formulas for x and y, but I'm going to find the angle in radians first. You're going to see why. It actually winds up being a nicer answer. So again, I'm going to start out with a 13 centimeters, which is arc length. And what I want to do is put a lap down here and a lap down here. The lap of arc length is 2 times pi times 5 times centimeters. The lap in radians, remember it's 2 pi radians is one whole lap around the unit circle. So that's one lap, that's one lap. Now, watch what happens. This winds up being a much nicer answer than 148.96. The 2 pi's just cancel, the centimeters just cancel, and all we get is 13 divided by 5. That's 2.65. No, just 2.6, sorry. 2.6 radians. So I'm just going to come over here and say 2.6 radians. We're going to erase the answer, and then we're going to check it. All right, now how do we check it? Here we go. Remember that going to the top is about 1.6. Going all the way over here is about 3.2. Halfway here is about 2.4. So when they told us 13 only got us to here, they were lying a little bit. 13 actually gets us, I'm thinking, more to over there. But I'm not going to fuss. They gave us the picture. I'm sort of stuck with it. All right. Next thing I would like to do is find x and y. You might ask why not find u and v, because those are actually a little bit harder. So this is what I'm going to do. I'm just going to stop right here and hope I can get away with this. I'm going to write down our formula for x. Our formula for x is r cosine theta. Well, r is 5. Cosine theta is cosine of 2.6 as long as I'm in radians. Now that is the exact answer. In my later calculations, that's what I'm going to use. 5 times cosine of 2.6. When I put that in my calculator, I get about minus 4.284 I'm not going to use that in the calculations because it's rounded and the calculations will get worse, but it's not a bad way to go. Remember, what do we do for y? Well, let's erase this so we can just do y. Y is equal to 5 times the sine of 2.6, like this. My calculator says this is 2.578 when rounded. I'm not going to use that calculation, that estimate in my later calculations. Put a little bar here and a little bar here. I'm going to get that y is equal to 5 sine of 2.6. It's positive. You can see that from the picture too. So I'm going to get something that looks like that, which is great. They now want u and v, right? Which actually aren't so bad. I don't know if I have room for them, but we'll try to put them down here. How about we just put this for a second? Yes. I can see from the picture, right, that v is positive because it's a length, and y is positive, and so v is just the same as y. So why don't we just put an equal to v right here and be happy with that? What's the difference between u and x? Well, x is a coordinate, not a distance. In fact, you have to actually go backwards to do x. So x is negative, u is positive because it's a length, and so what I'm going to get is that u is equal to minus x, right? So in this case, something like, 4.284-ish, which is great. And the last thing they asked for was w. This is the one that requires, I think, everything we have. But we now have a unit circle and a right triangle that involves w. So I can see right away here that v squared plus this whole length here, well, that's u plus 5. So I'm going to write down u plus 5 squared equals w, like that. If I put in what v is 5 sine 2.6. Now you might want to say, why not put in those numbers? Well, putting in the numbers makes the answer worse, and we're squaring things, and then we're going to take square root of things. That's just bad. U plus 5 is going to be minus 5 cosine 2.6 plus 5 squared. That's equal to w squared. Let's see here. This is what I have. I'm just double checking my arithmetic here. And I don't think that's quite right. I'm going to go like this, and hopefully I won't make a mess of it. We're going to see. And I got something like 92 and now I want all the decimal places because I want to take a square root of this. 844 437 67, and down here I can put my last conclusion. So w is the square root of that, and you can see that's going to be, I don't know, 9.5-ish, 9.6-ish, something like that. So we're going to get down here and over, and we're going to get 9.635 581 854. Ta-da! That's that whole problem. So we can crawl our way through this problem without too much effort. Long but not hard.